Previously, we discussed the evolution of generative AI from the 1950s to the 1990s, highlighting foundational theories, the Turing test, and the rise of neural networks. Today, we'll delve deeper into the pioneering research that laid the groundwork for these advancements. Let's start by exploring the early beginnings of generative AI in the 1950s and 1960s. This era was crucial for laying the theoretical foundations of what we now recognize as artificial intelligence. Key figures like Alan Turing and Norbert Wiener were instrumental in this phase. Turing, in his seminal 1950 paper titled Computing Machinery and Intelligence, introduced the groundbreaking idea that machines could replicate human intelligence. This concept, which included the famous Turing test, was pivotal in shaping how we think about machine intelligence. In 1956, a significant milestone occurred with the Dartmouth Conference, which is often considered the official birth of artificial intelligence as an academic discipline. This historic meeting brought together leading minds, including John McCarthy and Marvin Minsky, to explore the potential of machines to simulate human cognitive processes. It was here that the term artificial intelligence was coined, marking the beginning of AI as a distinct field of study. Moving into the 1960s, we see influential early work such as Joseph Weizenbaum's creation of ELIZA in 1965. ELIZA was an early example of generative technology in action, capable of simulating conversation with users through structured dialogue patterns. This demonstrated the potential for machines to mimic human interaction and laid the foundation for the development of natural language processing systems. As we transition into the 1970s and 1980s, we witness the rise of generative AI frameworks. This period was marked by advances in machine learning algorithms, which were game changers for AI. A notable innovation was the publication by Rumelhart, Hinton, and Williams in 1986 on backpropagation, which revolutionized the training of neural networks. This algorithm enabled the efficient training of multi-layer networks, a necessary development for more sophisticated generative models. During these formative years, researchers also began exploring new models capable of creating data that closely resembled actual datasets. This exploration laid the groundwork for systems capable of generating coherent text, artistic visuals, and even musical compositions that mimic human output. The 1990s marked a transformative shift in generative AI, driven by enhanced computational power. This era saw increased computational resources, which enabled the development of more complex AI models. Tools and frameworks became more accessible, leading to broader experimentation and the application of AI methods in real-world scenarios. Significant papers and innovations from this period include the popularization of hidden Markov models, or HMMs, which were notable for their application in temporal pattern recognition, such as speech and handwriting. HMMs provided a framework for making probabilistic models of sequences, advancing both the theory and application of generative AI technologies. The latter part of the 1990s saw generative AI being adopted across various industries for practical applications. Innovations from this era included the generation of synthetic images, compositions, and other automated content creation tools, signaling a transition from theoretical exploration to impactful practice. As these foundational theories developed, they began to manifest in tangible applications. By the late 1990s, generative AI was being used in industries such as entertainment for synthesizing music and visual content. The use of HMMs in speech recognition also paved the way for modern virtual assistants. Despite the historical aspect, recent research continually revisits these formative theories to enhance understanding and capability. A resurgence in interest around historical AI models helps refine modern applications and scalability strategies. In conclusion, these early decades in the history of generative AI were vital in setting the stage for future advancements. By building a strong foundational understanding through pioneering research, subsequent innovations continue to evolve in ways that impact both technology and society. This pioneering era laid the groundwork for the sophisticated and impactful generative AI systems we know today. Understanding these early milestones helps in appreciating the trajectory of AI's evolutionary path. Next, we'll explore the major AI advancements from the 2000s to the 2010s, including the emergence of generative models and the rise of GANs, which revolutionized data realism and set the stage for future AI evolution.